The final type of transformation that we need to talk about with matrices is rotation. And rotation can actually be the trickiest one. The reason for that is if you are not carefully reading your directions, you may screw up which direction you are supposed to rotate. Now, rotations are done the same way as reflections. We're going to start with one of these three matrices, and we're going to multiply this matrix times our vertex matrix. Now, notice that these rules are based on the word counterclockwise. Now, we all took trig last semester, which means we know that if we read the word clockwise, those rules would be basically backwards. We're looking at three rules. If we're rotating clockwise, a 90-degree counterclockwise rotation is exactly the same as a 270-degree clockwise rotation. 180 degrees counterclockwise is the same as 180 degrees clockwise, and 270 degrees counterclockwise is the same as 90 degrees clockwise. So we have to read the directions carefully. We have to make sure we're using the correct rule. So on our first example, it says to rotate 270 degrees counterclockwise. So we go to our rules and we find the rule for 270 degrees counterclockwise. So 270's here, which means we're starting with the matrix 0, 1, negative 1, 0. So we start off with that rule, 0, 1, negative 1, 0, because that's what it says, 270 degrees counterclockwise. And just like we did with reflections, we are going to multiply our vertex matrix by that matrix, or this matrix times our vertex matrix. So A is located at the point negative 5, 6. B is located at the point negative 2, 1. C is located at the point negative 5, negative 4. And D is located at the point negative 8, 1. We are going to carry out matrix multiplication, row times column. So that would be 0 times negative 5 plus 1 times 6, 0 times negative 2 plus 1 times 1, 0 times negative 5 plus 1 times negative 4, 0 times negative 8 plus 1 times 1. Then we're going to repeat those steps with row 2. So negative 1 times negative 5 plus 0 times 6. Negative 1 times negative 2 plus 0 times 1. Negative 1 times negative 5 plus 0 times negative 4. And negative 1 times negative 8 plus 0 times 1. Each of those will be reduced down to a single point, which would be 6, 1, negative 4, 1. 5, 2, 5, 8. Again, we've said this many times over the course of these last few videos, those are our image points, A prime through D prime. So we're going to go to our picture, we're going to graph those points. 6, 5, 1, 2, negative 4, 5, and 1, 8. And then we're going to play connect the dots. So we're going to connect those 4 points together. Oh, that is not the right, well, that's not what I wanted. I want a red. There we go. So we're going to connect those 4 points together, forming the same diamond, which has been rotated 3/4 of a turn clockwise, which is the same, note, the same as a 90-degree clockwise turn. So we've rotated. This is point A, this is point B, this is point C, and this is point D. Let's do another one. Now this time, notice that instead of counterclockwise, it now reads clockwise. So this is going to be our rule for 90 degrees counterclockwise. So we have to read carefully or else we'll mess that up. So we go back to our rules and we look for the rule for 90 degrees counterclockwise, which is 0, negative 1, 1, 0, and that's what we start with. 0, negative 1, 1, 0. And we multiply that by our vertex matrix. So again, we need to go through and label our points. There are 5 of them this time. A is located at 1, 1. B is located at 6, negative 2. C is located at 4, negative 7. D is located at negative 2, negative 7. And E is located at negative 4, negative 2. Now I don't have enough room to write my work here directly underneath, so I'm actually going to put the work down here at the bottom where I have more room. But it's the same thing. Row 1 times each column. So that's 0 times 1 plus negative 1 times 1. 0 times 6 plus negative 1 times negative 2. 0 times 4 plus negative 1 times negative 7. 0 times negative 2 plus negative 1 times negative 7. And 0 times negative 4 plus negative 1 times negative 2. That's row 1 times each column in order. Then I do the same thing with row 2. So row 2 times column 1 would be 1 times 1 plus 0 times 1. Row 2 times column 2 would be 1 times 6 plus 0 times negative 2. Row 2 times column 3 would be 1 times 4 plus 0 times negative 7. Row 2 times column 4 would be 1 times negative 2 plus 0 times negative 7. And row 2 times column 5 would be 1 times negative 4 plus 0 times negative 2. And again, each of these is going to get simplified down to a single number. So we're looking at negative 1, 2, 7, 7, 2, 1, 6, 4, negative 2, negative 4. Now let me just restate, I know that there are shortcuts to this. I'm fully aware of that. But we are studying matrices, which means I'm looking for applications of matrices. And that's what we have here. So I do expect to see the work. So let's graph those points. Negative 1, 1, 2, 6, 7, 4, 7, negative 2, which is right in the middle of my B, so let me move the B here. Seven, negative 2, and 2, negative 4. Connect the dots. And there's our image. A prime, oops, A prime, B prime, C prime, D prime, and E prime. That does it for our project, or our notes for our project. Now please be advised, I've said this before in class, but I'll say it again. The project is very detail oriented. If you make a mistake on step 2, you may not notice until step 6. And you will have to start over. So make sure that you are taking your sweet time, because your answer to number 1 is your starting point for number 2. Your answer for number 2 is your starting point for number 3, etc. And if you make a mistake, you may not notice for several steps. The entire project should stay on that coordinate plane that I provided you with. If it does not, then you have made a mistake. See you in class.